Assalamualaikum warahmatullahi wabarakatuh and good morning. Today we'll be continuing our chapter on thermodynamics. Now we'll be looking at chapter 3.2, which is the continuation of the first law of thermodynamics, and we'll also be looking at the second law of thermodynamics. In this chapter, we'll be introduced to SFEE devices for open system, introduction to a second law of thermodynamics, and introduction to the heat engine cycle. First, let's look at common devices of steady flow energy equation, or SFEE for short. The steady flow here means that the mass of the control volume CV is constant with time. The common SFEE devices are nozzle, diffuser, filtering valve, turbine, compressor, mixing chamber, and heat exchanger devices. All the devices is open system devices because SFEE is only used in open system. Now let's look at nozzle and diffuser. So what is nozzle? Nozzle is a devices that increase the velocity of fluid that travel through its chamber, which will result to decrease of the pressure. While diffuser is devices that increase the pressure by reducing the velocity of fluid travel through its chamber. These devices are commonly utilized in jet engine, rocket, spacecraft, or even coast garden. One must remember that these devices have only one entrance and one exit. Since these devices is application of the first law, it is known to us that the mass flow rate m dot is conversed throughout the entire process. For nozzle and diffuser, the process of fluid flow through the chamber is considered adiabatic, where there is no heat transfer occur, so Q is equal to 0. Since there is no change in the elevation at entrance and exit, the potential energy also is equal to 0. Work is also equal to 0 because there is no change in the volume. So rewriting the first law of energy equation, we will get H1 plus C1 square over 2 equal to H2 plus C2 square over 2. Next, we'll be looking at turbine. Turbine is a device that produces work by expanding fluid flow through its chamber. The work produced is known as workout, or W out for short. This device has only one entrance and one exit. Since it is a SFEE devices, the mass flow rate is also conversed throughout the process. Turbine also devices that consider working in a adiabatic process where there is no heat transfer occur, so WQ is equal to 0. There is also no change in the elevation at entrance and exit, so the potential energy is considered 0. We rewrite the first law energy equation, and we will get work out, or W out, equal to m dot times H1 minus H2 plus V1 square minus V2 square over 2. Now let's look at compressor. Compressor is a similar device as a turbine, but instead producing work. Compressor require work to transfer the fluid in the chamber. The work provided to the compressor is known as work in, or W in for short. Work in is required in order to increase the pressure in the compressor. This device also has one entrance and one exit. Since it is an SFEE devices, the mass flow rate is also conversed throughout the process, so m dot is constant. Similar as a turbine, compressor also a device that consider working in an adiabatic process, and the potential energy also is considered 0. Since the system is receiving work, so the work is in negative. So rewriting the first law of energy equation, we will get work in, W in is equal to m dot times H2 minus H1 plus V2 square minus V1 square over 2. Now let's look at valve or throttling device. This device is a simple device with one entrance and one exit. Since it is also part of SFEE device, the mass flow rate is also converse. A fluid that travels throughout the device will experience a pressure drop. The device also working in adiabatic process, so the Q is equal to 0. With kinetic energy, potential energy, and work is equal to 0, the equation will only leave us with H1 equal to H2. Now let's look at second law of thermodynamics. The, the second law of thermodynamics states that a process can occur in a certain direction or not just any direction. Example, gas expanded from a high pressure to a lower pressure. In other words, gas moved from high pressure area to low pressure area. Next, heat flow from a high temperature to a low temperature area, like a cup of hot coffee losing heat to surrounding and become cold. And next example is about water flow down a waterfall. Well, this is a common sense. Water from waterfall would never goes up from lower ground to higher ground. Like pouring water from a cup, the water definitely fall down from the cup, not going upward. This is also the same for heat engine. We can never convert completely 100% the heat supply to the heat engine into work. There must be some losses. This happens without fail in the real world. There will be inefficiency involved. We at least try to get an efficiency which is close to 100%. So what is heat engine? Heat engine is an energy conversion system which operates in thermodynamic cycle. From a heat engine, we desire a work output. To get the work, a heat supply is required. To put it simply, heat engine convert heat to work. The heat engine operates between two heat reservoirs. One reservoir can be called high temperature reservoir, is where it receives heat to convert to work and where the net heat is transferred. Another reservoir is used to reject remaining heat or excess heat that cannot be converted to work. This reservoir usually called low temperature reservoir or heat sink. The heat sinks that commonly used is the atmosphere, since it is cheap and efficient. Alright, now this is the example of heat engine in the steam power plant. The work process of heat engine can be shown as follows. The fluid in heat engine receive heat QH from high temperature reservoir, which the temperature is at TH. H stands for high. The heat from heated fluid is then converted to work, which is W net out. Then the excess heat QL of the fluid which cannot be transferred to work is released to the lower temperature reservoir at TL. L stands for low. The cool fluid then is pumped again to the heat engine to create another cycle of workflow. This is the common heat engine that you will be seeing quite a lot in the future. So please remember the workflow and the diagram of the heat engine cycle. Heat engine usually consists of a boiler where it receives heat QH, a turbine where the heat is converted to work W net out, a condenser where the excess heat QL is released to the atmosphere, and a pump where it used to move the fluid in the heat engine. Okay, pump require work to move. The work is known as W in or work in. Alright, that is all for today. So for today homework, please answer the given question and submit it by the next class. Okay, the first question is about turbine. This device is an application of SFEE device. And this second question is about nozzle. This device also is application of SFEE devices. Alright, thank you very much for your time. Assalamualaikum warahmatullahi wabarakatuh.